Hi, everyone. This is Aaron Larson, Executive Editor of Power Magazine, and you're listening to the Power Podcast. On today's episode, I'm joined by GreenFire Energy's CEO, Joseph Scherer. He is based out in California. And Joe, can you talk a little bit about the company and what you guys do?
Sure. Happy to do that. Thanks for having us on. At GreenFire Energy, we develop and deploy what we call our Green Loop technology to significantly expand the usage of geothermal energy for economic power generation and certain high-value industrial applications. Green Loop technology captures, transports, transforms previously inaccessible geothermal energy. The Green Loop innovation, closed-loop solutions extract energy from a broad spectrum of geothermal resources where conventional geothermal technology doesn't perform well or degrades over time, which happens to include the vast bulk of the world's geothermal resources. Also, unproductive geothermal or oil and gas wells can be retrofit with our technology to be productive again. And the basis for our Green Loop technology is that it's a closed-loop system that continuously circulates a working fluid within a sealed, closed system to absorb and deliver the thermal energy to the surface. No fracking, injection of fluid into the resource, or removal of fluid from the resource is required. So it has the best environmental characteristics of any renewable energy technology. And we use a variety of working fluids in the closed loop, including water and various refrigerants, depending on the characteristics of the well and the geothermal resource to optimize performance. And the working fluid absorbs heat as it traverses the lower part of the well and then flows to the surface, where the heat is either converted to electrical power, delivered as thermal energy for specialized purposes, or optimized to deliver both on a flexible basis. So our Green Loop technology often produces only heat rather than fluid mass to the surface. So the Green Loop has an important advantage of maintaining fluid and pressure in the geothermal resource as a whole to preserve the productivity of the resource long term. And due to the diversity of the geothermal resources and the versatility of the technology we're dealing with, all our Green Loop systems are planned and engineered using our proprietary integrated thermodynamic and geothermal resource modeling to design each system for the optimal performance of the resource. And this is coupled with a sophisticated well cost model to accurately predict project economics. So together, all these models and experience can enable a rapid resource assessment and project feasibility determination. That's what we do.
It sounds like you do a lot. That's really a great explanation of how the geothermal loop works. You did a recent demonstration, a field demonstration. Can you talk a little bit about that and what went into that project and what it actually accomplished?
I'm happy to explain this. It's our demonstration project at Coso, California, which is a large and very hot known geothermal resource area. The project was principally funded by the California Energy Commission with additional support from Shell Oil and the Electric Power Research Institute and one of its member utilities, J-Power, which is a large Japanese utility with geothermal assets. But the biggest thank you goes to the folks at Coso, who are super supportive and helpful. Anyway, at our Coso demo, we were able to insert a tube-in-tube heat exchanger, 1,000 feet long, into an existing geothermal well that couldn't be used due to the high concentration of non-condensable gases. And we made over 1 megawatt of power, even though the project wasn't really at full commercial scale. And with these results, we were able to validate the modeling we used to predict performance of our various closed-loop solutions in a variety of geothermal resources. And we have various papers downloadable from our site explaining this in great detail.
It sounds really interesting to me, and I'm a big proponent of geothermal energy, and I'm really excited about the prospects for dry rock geothermal, where you're going down 6 to 10 kilometers deep, and it's basically extracting the energy through a closed loop, I guess similar to what you're doing. Can you explain, I guess the results from your demonstration actually show some promise for deep dry rock geothermal. Can you talk about that at all and what you see as a future for that technology?
Yeah, and you're right. But there's actually a whole spectrum of geothermal resources, from highly permeable resources with lots of water and pressure in the resource at one end of the spectrum, where conventional geothermal technology works fine, just fine, and impermeable resources and resources where the water is depleted on the other end of the spectrum. So keeping the spectrum in mind, our green loop approach is a solution for geothermal resources both in the middle of that permeability water spectrum and at that impermeable dry end of the spectrum that you just referenced, and that's what's typically called hot dry rock. So for resources in the middle of the permeability water spectrum, where conventional geothermal systems are challenged, often because the resource is still hot but has degraded somehow, our green loop approach has a variety of immediate opportunities. And these are highly economic because a closed loop system can be inserted into existing wells to retrofit them to extract heat, and there's no need to drill the well. The well and all the related infrastructure is already there. And all the technical data about the well is readily available. Information about the resource is readily available. So a specifically designed and tailored green loop system can be easily added. And the paybacks on these well retrofits are in the 1 to 3 year range, and that's without counting the substantial savings of not having to plug and abandon an unused well. And we're only harvesting the heat and typically not removing water from the resource or reducing the reservoir system pressure. So these retrofits can provide a roadmap for vastly expanding power production from the geothermal resource with a new purpose-drilled well system using the same green loop technology. So this middle range of that permeability water spectrum is just a huge opportunity for us right now. As for the truly hot, dry rock at the other end of this water and permeability spectrum, I heartily agree with your excitement about harvesting those resources. Indeed, that's considered the holy grail of geothermal opportunities, as the Earth's accessible heat portends power orders of magnitude greater than any other renewable. But extracting it without finding or creating fractures and keeping water circulating in those fractures for decades at a time is the challenge. And we've shown in our modeling that it's sufficiently hot rock with closed loop pipes contain the right working fluids and flowing at the right rates. And in contact with that rock over sufficient length, we can harvest and heat harvest the heat and be economic. Indeed, at Coso Resource, we did our demonstration project, and where there's a lot of hot, dry rock, in addition to more permeable resources, water. And we analyzed the potential at Coso for a hot, dry rock approach, and determined that we could take a resource that currently produces at about 140 megawatts and produce 2 gigawatts. That's 14 times more power at current market prices, assuming they're sufficiently large projects.
I'd like to go back to that middle spectrum that you were talking about, and you had mentioned potentially using old or abandoned oil wells and these other geothermal resources that are perhaps no longer useful in their current state. Where can you do this? Can this be done around Texas and other areas that have abandoned oil wells or no longer useful oil wells? Or is there specific regions like in California that you have to be in to accommodate these?
Good question. And as you can imagine, the oil and gas world is very interested in this. Indeed, we've been in the Shell Game Changer program for a number of years. And our first project for Shell was to answer that question in particular. What are the characteristics of oil wells where we could use our system to retrofit them? And as you can imagine, some oil wells are not chosen because they're hot. They're chosen because they have oil. Right. But where there is sufficient heat and where there's sufficient diameter, oil and gas wells tend to be smaller diameter than geothermal wells. Yes, it can work. And in particular, special applications, it has the opportunity to work where there's a special reason. Say it's an off-grid location where you're having to bring in diesel fuel. So the price of fuel that you're having to bring in to pump the oil field is high. Well, that can work just fine. Another application that we're spending a lot of time on now is offshore oil platforms, where there's a high temperature differential between at the seabed, and there's also special and large power needs on the platforms, and a lot of motivation these days for the oil and gas industry to get green. So yes, the answer is yes, sometimes, but not overall, going into every oil field and retrofitting them.
Mm-hmm. When you talk about doing it offshore, would these just be small generators, like a handful of megawatts or less, or how big would they be?
Well, the easiest first, low-hanging fruit there is for the platforms themselves, the drilling and production platforms themselves. But there is a good deal of talk, and I think it's currently mostly talk, but about doing this on a full production basis and sending the energy back to the shore. And one alternative is capturing it as hydrogen and sending it to the shore. The other, of course, is long electrical cables. But I think the initial application is going to be for offshore usage in the offshore context.
So thinking about the hurdles to greater implementation of geothermal, what sort of things have to be overcome in order to make it more sustainable and more viable around the world?
Partly, it's changing the mindset about geothermal energy. As I'm sure you're aware, geothermal energy is vastly underutilized. It's a very much overlooked resource. It's our most abundant energy source, but constitutes really only a small fraction of the power produced. And in terms of public perception, we need for people and government agencies to recognize the inherent advantages of an always-on resource like geothermal with environmental characteristics that are better than any other renewable, in its closed-loop variety at least. And compare that to the intermittent renewables such as wind and solar, which need extensive battery support for reliability and grid flexibility. Fortunately, agencies like the California Energy Commission and the California Public Utilities Commission have recently issued reports targeting big increases in geothermal power to address the grid needs arising from intermittent renewables. So, and as for government financial support, geothermal will certainly benefit from having a level playing field with the same sort of tax and other subsidies that have been afforded to wind and solar. And then also streamlining the permitting process for developing new geothermal fields is important, as new greenfield geothermal projects do take a long time to develop.
Yeah, I guess I don't know a lot about what the permitting. I know permitting for other plants is often very difficult, so I'm sure it's just as difficult for geothermal.
One of the things that's interesting about closed-loop geothermal, and so we've talked to some regulators about this, and when you're keeping everything in a closed loop and you're not interfering or interacting with the water table or potential for contamination and whatnot, there's not that much to regulate. So it could be that closed-loop geothermal will be a way of accelerating the permitting process, and we certainly hope so, and we've been told that by regulators.
That's good to hear. Now, you had earlier mentioned about the working fluids, and I know water has been used. Supercritical CO2 is another one I understand that has advantages and disadvantages. Can you talk about the alternatives and when one option might be used over another?
Yeah, actually, a wide variety of working fluids can be circulated into a closed-loop system. That's one of the key advantages, and we choose the optimal fluid to use, taking a variety of factors into account. So, for example, water is often the best, especially where we're integrating with a steam-based power generation system on the surface. However, refrigerants, such as supercritical CO2, which we tested at Coso in detail, are highly compressible without changing phase. So they set up a strong thermosiphon as the weight and density of the fluid going down is so much heavier than the hot fluid coming back up. And indeed, we tested it at Coso and demonstrated the strength of the thermosiphon that's developed. So one of the keys to optimizing performance is to model the well and the resource using a variety of working fluids and choosing the best one. And that's an inherent advantage because we're not stuck. We can choose whatever working fluid is best.
And you also mentioned that you worked with EPRI, the Electric Power Research Institute. Can you talk a little bit more about how they're helping you to develop technology and maybe make this more mainstream?
Yeah, EPRI's been a great partner for us. As they took an early interest in our technology and helped support our Coso demo. But they have a number of member utilities across the world and have interested several in our technology. And the particular project we're doing for the EPRI now is to look at the potential for closed-loop geothermal technology in Japan, which has great geothermal resources, as you can imagine. Mm-hmm. And we're anticipating that real projects will emerge from that assessment. So that's what we're doing with EPRI right now, but we really appreciate EPRI.
No, they do a lot of good work, and we have a partnership with them as well on some different conferences we do, so I have a lot of good relationships with EPRI. Now, I was reading, actually, that your company was recognized by Lux Research as one of the best tech startups and groundbreaking developments in the thermal power generation category. Has that helped kind of get the word out about GreenFire Energy and what you're doing and perhaps spurred even some investor interest?
Yeah, it's nice to be recognized for this by Lux, and we respect them a lot. Besides understanding GreenFire as a company and our technology, I think Lux also understands how we stand to benefit from the big factors driving the energy transition. And in particular, the oil and gas industry is looking at geothermal, particularly closed-loop geothermal, as a natural path for them in the energy transition. Beyond that, closed-loop geothermal interest is driven by climate change concerns, as we're carbon-free resource that provides baseload power, not intermittent like wind and solar. And as I've proclaimed at many conferences, we have the best environmental characteristics of any renewable energy source, as typically graded by emissions, potential contamination, geographic footprint, and impact on wildlife. And Lux picked up on all that, I think, and so we appreciate it in addition to their review of the specifics of our company.
You also won an award from the Department of Energy for a new thermal drive pump. Can you talk a little bit about that design and how that is beneficial?
Yeah, the GreenLoop technology has versatility, and that's a good example of the versatility that we have, as we received it as part of the Department of Energy's American-Made Challenge program to advance what we call our thermal drive pump, which actually uses geothermal heat captured in a closed-loop system to create this thermosiphon we talked about earlier. But in this case, to power a downbore pump that can pump water or oil to the surface without having to use electronic submersible pumps or other pumps that take a lot of electricity and often have longevity issues. So likely the best application for this technology is for pumping oil to the surface, which makes the oil and gas industry more green. And that's a key goal for the oil and gas industry. So we are happy to have won that award, and we're planning on going to the next stage with that process, the American-Made Challenge.
It seems like there's no end to things that your company is doing. I read that you signed a partnership with Semesta Energy Services on geothermal projects in Indonesia. Can you talk about the benefits and what you hope to gain by partnering with that company?
Yeah, Semesta is well connected in Indonesia with the geothermal industry, and Indonesia and the Philippines are poised to take over the leading geothermal position worldwide from the United States. And that's good from a climate change perspective as well, because those economies are developing rapidly and their power usage is going to go up as well. So if you think about this from what resources you want to displace with truly green energy, emerging economies are ideal. But more from a business case point of view, Semesta is our local partner. It's necessary to work with a local partner in Indonesia. And they understand the companies and have the resource, and they've introduced us to the largest owner-operator in Indonesia. And we're talking with them about reviewing some of their projects that are in this middle range of the permeability water spectrum I talked about earlier. So that's the first opportunity there, but we hope to move from that over time into the hot dry rock world as well.
So do you actually build plants, or you take your design and build them for companies and basically sell them to the power end users, or how does that work?
Well, there are two business models. One is, and if it's a small project, then yes, we just sell them the equipment and install it and test it, show them how to operate it, and move on. But as the technology and the opportunities develop over time, they become project finance opportunities, which is actually my background. I spent 30 years as a project finance lawyer. And that involves building a business essentially for each project that becomes its own business and then sells, leases whatever it needs from the resource owner, and then sells power back to the utility. Typically, or to the geothermal owner, if it happens to be a geothermal owner host that is using the power. So there are two different business models, and then there are combinations of those. But one would be the fabricate and sell, and the other is to put together a project financed business that owns and operates the resource itself.
I see. Yeah, and you did earlier talk a little bit about how tax credits are used, particularly in the solar and wind industry. Are there any available for geothermal projects?
Yeah, that's a sore point in the geothermal area because there have been such advantages given wind and solar, and there is a movement by Geothermal Rising, formerly known as the Geothermal Resources Council, to make a level playing field in that regard. So yeah, that's an area that needs work for sure.
Yeah. So there isn't, at the present time, there's just really nothing available that would help with tax credits or anything.
Nothing special has been afforded other renewables.
All right. Well, Joe, thank you so much for taking the time to talk with me. Is there anything else that you want to bring up before we wrap up the podcast?
Well, just one other thing, and because of the versatility that our Green Loop provides, another application for our technology is the green hydrogen revolution that has now been launched. And as green hydrogen is now considered the fuel of the future. And we were actually asked by a super major oil and gas company to look at whether using geothermal heat down bore in our Green Loop system could make green hydrogen more efficiently. And happily, the answer is yes. Since green hydrogen production is more efficient at high temperatures and often benefit from high pressure, and since high temperatures and high pressures are free and deep down in a geothermal resource, we can indeed substantially improve the efficiency of hydrogen production. So that's great. Also, though, compression of hydrogen produced on the surface for transportation and other purposes is also expensive. And we have the additional advantage in making hydrogen down bore at high pressure so that you don't require as much compression that's required, that is needed at the surface. So we're not commercial with this application yet, but we do expect to develop it over the next 2 years, and we have support for that. And geothermal isn't traditionally regarded as sexy, but hydrogen is. So our plans to make hydrogen with geothermal energy makes GreenFire and geothermal sexy, right?
Mm-hmm. Hydrogen is really the buzzword right now. Every company seems to be doing something about hydrogen, whether it's building their gas turbines to utilize it or somehow developing storage mechanisms with it. And, stories about hydrogen get a lot of traffic on our website. So you're right, it is a sexy technology right now.
It's an ideal fuel in so many ways, but the problem is for most of the green hydrogen stuff you hear about, they're assuming low electricity prices so that they can assume competitive hydrogen prices, competitive compared to other fuels. So what we do is actually reduce the cost of hydrogen production significantly. So all of those applications of hydrogen are great, but you have to make them economic, and that's what we're doing.
All right, Joe, thank you so much for your time. I appreciate it, and look forward to maybe catching up with you again down the road when some more of these projects get completed.
I hope so. Thanks for your interest. We appreciate it.